Sometimes we're asked to solve an equation and we just don't know how to do it. Something like this: 4x cubed minus 3x equals 38. And really we don't know where to start with that one. It's maybe beyond us in the content of the course. We've not come across cubics and how to solve those, and really that's something that's done at A level. But we can still try and get a solution for this by what's called trial and improvement. And what we do is we guess an answer for x, and we see how good an answer that gives us, and then we improve on that value. We try and find a better answer for x. And we do that in a number of stages. The first stage is we try and find an answer between two consecutive whole numbers. And once we've done that, then we narrow it down a little and try and get more and more accurate. We try and find the answer between consecutive first decimal place numbers. So something like between 1.7 and 1.8. And then our final stage, and we always have to do this all the way up to GCSE, we check halfway between those consecutive first decimal places. So let's have a look at an example here and see how this works. So here we're asked to solve x cubed plus 3x equals 70. And that's not something I'm comfortable solving, really. It's not something we could do. So what we're going to do is we're going to guess an answer. And I've started by guessing an answer of 4. X is 4. And the way we set this out is we have a column for all our guesses for x. The left-hand side of this equation, the x cubed plus 3x, we have a column for that. And then we have a column for comment. And that comment is going to be either the answer's too big or the answer's too small. Now, in this one here, I know that x cubed, well, I know 2 cubed is 8. I know 3 cubed is 27. I know 4 cubed is 64. So 64 is close to 70. So that's why I've picked 4 to start with here. So everywhere I see x in this equation, I'm going to write 4. So instead of x cubed plus 3x, I'm going to write 4 cubed plus 3 times 4, or 4 cubed plus 12. And that's equal to 64 plus 12, 76. And this is very definitely a calculator method. We can just plug this into our calculator, 4 cubed plus 12, and the answer comes up 76. Again, if you have your calculators, hopefully you can just about see this. If I want to do a cube, there's 4. This little button here, x to the power of, if I press that, it comes up as a power, and then I can press cubed. So if I do 4 to the power of 3, I get 64. And so when I do that whole thing, 4 to the power of 3, and then I want to move myself down on the display, and then I'm adding 3 times 4. And when I put that in, you'll see hopefully that comes up as 76. Now, 76 is the answer when we put 4 in for this, but we wanted 70, so that's too big. So 4 gave me an answer that was too big, so I want to keep going with the whole numbers. I'm going to try 3. And so when I put x as 3 here, that's 3 cubed plus 3 times 3, and I know that's 9, so I'm going to put that in. And again, on my calculator, just very quickly going to do 3 cubed plus 9, and that ends up as 36. You can see we want an answer 70, so 36 is too small. Now, 4 gave me an answer that's too big. 3 gave me an answer that's too small, so I know the answer has to be between 3 and 4. They're consecutive whole numbers. And now that I have the answer between consecutive whole numbers, I'm going to go for consecutive first decimal places. Now, you can see here, when I put 4 in, I get 76. When I put 3 in, I get 36. The answer seems to be closer to when we use 4 for x rather than 3. So I'm going to look somewhere between 3 and 4, but closer to 4. Let's try 3.7. when x is 3.7, x cubed is 3.7 cubed plus 3 times 3.7. Again, we can put that into our calculator, and when we do that, 3.7 cubed plus 3 times 3.7. And when we do that, we get 61.753. Now we're looking for 70, so that the comment there is, that's just a bit too small. Well, let's move up the decimal places then. If it's 3.7 is too small, what about 3.8? So 3.8 cubed plus 3 times 3.8 is equal to, and when you put that into your calculator, you should get 66.272, which again is too small. We want 70. So we'll try one more. Let's go 3.9. So when x is 3.9, that's 3.9 cubed plus 3 times 3.9. And when we do that, put that into our calculator, we get 71.019. We want 70. That's too big. Now, just like when we did the consecutive whole numbers, we said this was too big and this was too small. I now know that 3.8 gives me an answer it's too small. 3.9 gives me an answer it's too big. So really I know that my answer is somewhere between 3.8 and 3.9. It's in this gap here. 3.9 gives me an answer it's too big. This is too small. And this is the third stage in. We now need to pick somewhere halfway between. So we pick the midpoint, 3.85. And we do exactly the same thing. 3.85 cubed plus 3 times 3.85. And when you put that into your calculator, you get 68.616625. We want 70, so that's too small. So this is now too small. This is no use to me. The answer's somewhere in this region. 3.85 is too small, 3.9 is too big. But if I'm giving my answer to one decimal place, the answer then is going to be closer to 3.9 than 3.8. And so we've given an approximate answer. It's a pretty good approximation to this question. But what about the original one I asked you about? This one's slightly trickier. We just need to be slightly careful with this, but we're going to go about it in the same way. I'm going to pick a value for x. I'm going to look at the left-hand side here, 4x cubed minus 3x, and I'm going to have a comment as well. And so let's just make sure that we have a table for this. And every time we do this trial and improvement, we want to do a table just like this. So let's see. One thing I need to be very careful here, guys, is 4x cubed. Well, BIDMAS tells me indices come before multiplying. So 4x cubed actually means 4 multiplied by x cubed. So we have to cube x first and then multiply by 4. Now, doesn't tell us where to start. I know roughly x cubed, 2 cubed is 8, and 8 fours are 32, so that's quite close. So I'm going to start here with when x is 2. So when we do that, put it 2 in for x here, that's 4 times 2 cubed minus 3 times 2. And you put that into your calculator, you should get 26. We want 38. So that's too small. So 2 gave me an answer that was too small. Let's try 3 then. So 4 times 3 cubed minus 3 times 3. Now even before I put this into my calculator, I know that 2 cubed is 27. So 4 times that's going to be 108. This is going to be quite big. But when you put that all into your calculator, you get 99, which is way too big. I see our answer here, 26 is closer to 38 than 99. So I'm going to maybe say, okay, let's try 2.3. The answer is going to be closer to 2 than it is to 3. So 4 times 2.3 cubed minus 3 times 2.3. And that gives me an answer of 41.768. And you'll notice just the way that I'm writing that down each time, I'm showing my method here. But that's just too big. I want 38, not 41.7. So 2.3 was too big, 2.2. So 4 times 2.2 cubed minus 3 times 2.2. And when we put that in, we get 35.992, which is too small. But I do now know that when I get 2.2, I get an answer that's too small. 2.3 gives me an answer that's too big. So really my answer is somewhere between 2.2 and 2.3. Too big, too small. So let's try halfway between, which is 2.25. So 4 times 2.25 cubed minus 3 times 2.25. And that gives me an answer of 38.8125, which is close, but it's still too big. So this gives me an answer that's too big. This is all not needed. My answer is somewhere in between 2.2 and 2.25. So in other words, to one decimal place, it's closer to 2.2 than 2.3. So to one decimal place, x is 2.2. And so we've solved this equation, or we've found an approximate answer for this equation using trial and improvement.